And then 0, 1. Yeah.
Okay. Sorry, Becca, I'm not finding yesterday's graphing.
That would be
So, on that numbers of each other, thank you.
All right. So Friday, there's a quiz that you need to be able to graph, which was yesterday and what we're going to start with today. And you need to be able to do things that were on the exit card, which is apply the laws of, the rules of logs. Be able to expand, be able to condense, be able to evaluate, be able to translate from log to exponent form, exponent to log form. I haven't finished, but there's something out there right now. There's an optional, but highly recommended, optional Delta Math, because some of you are like, I need more practice on this, I don't get it, what's going on? So I'm putting in all of the different kinds of questions, and you can practice the thing, pick and choose what you personally feel like you need practice with. You don't have to do the whole assignment, you don't have to do any of it, but it's out there for those who wanted stuff. Okay, so the way that I showed you guys how to graph, I am asking for 2 coordinates on every graph and a correct asymptote. And if you get those right in the general shape of the curve, that's a successful graph. What were the 2 coordinates that you need to know on every one? Joaquin, what's one of them?
1, 0, and then base, comma 1.
Okay. Base, comma 1. All right, yes. So this is my parent function. I'm going to put in my axes, and I'm going to plot the 2 coordinates he just said. From my origin, my real origin, I'm going to go over to 1, 0, and base, comma 1. So 1, 2, 3, 4, 5, up 1. And I forgot to check. Dylan, where is my vertical asymptote?
It's x equals 0, right?
So the vertical asymptote is going to be whenever that argument, that stuff in the parentheses, is 0. So vertical asymptote. So the things that you need correct on the graph, the vertical asymptote and those 2 coordinates. And then you got to kind of get the shape right. So it is technically a curve. That's what it kind of looks like. Right? So I'm not going to give you the easy one on Friday. Yes, Natalie?
Is there going to be any graphs on the test where that's in like a different spot?
Yeah. So
Like on
this.
the other side of the...
Oh, okay. I'm not going to make you reflect things or I'm going to ask you to do something like this other side. So this one, putting in my axes, here, what was the thing that, how does this whole thing move? What are the transformations? How does it shift from this original function?
It goes up 2.
Goes up 2.
And left 5.
Okay, because we know what transformations do. We had geometry, we had algebra 1, and we had algebra 2, those transformations. All right, so I'm going to move my real green axes. I'm going to pretend move them. 1, 2, 3, 4, 5, back 5, and up 2. My origin is still where the green lines cross, but my pretend origin is where the little purple guys are. And now I'm going to graph the things that Joaquin said from there. I'm going to go to my fake axis, origin, and I'm plotting 1, 0, and base comma 1. And graphing. Yes,
How would you find that X answer?
okay. First thing, are we okay with that idea of graphing? Ella?
Well, where's the 1, 0?
Okay, so my real origin is here. She told me that looking at these things, the function got moved up 2 and left 5. Do you know that that's what, okay. Oh, and the left 5, where is that argument 0, setting it to 0 and solving? That is the equation of my vertical asymptote. So, vertical asymptote, x equals -5. And then, so Ella, I did what she told me to, and I put in, I moved left 5 and up 2. So from here, it's not really my origin, but it's, if I move things, it's where my origin kind of wanted to be. And now I'm going to plot the 2 coordinates that Joaquin said earlier. 1, 0, base comma 1. And then draw the line. That's it. That's it. That's it. This is as simple as I can make graphing logs be. But,
Thank you.
I was asked how to find intercepts and stuff. Okay. All right. To find the y-intercept, I'm going to make x 0. So plugging in 0, I get log base 5 of 0 plus 5. And I do expect you to be able to evaluate that. Log base 5 of 5. 1. That's asking. If you don't know, if you can't see it, that's saying 5 to what power is 5 to the first? Those powers are in the same spot. So this is a 1. So the coordinate 0, 3 is where it's going to hit the y-axis. And look, your graph is there. Woo! We did it right. Touchdown. Oh, school. Crowd goes. Okay, fine. Okay, that's y-intercept. Okay? X-intercept, don't want you to panic, because x-intercept can get ugly. Kevin, what's the y value when we hit the x-axis? It's one of those days, okay. It's the opposite thing. If you're looking for where does it hit x, make y 0. If you're looking for where x, or the y, it hits the y, make x 0. Okay, so Spencer, I don't have a y written here. What?
Like, it's just a 0 equals.
The g of x is the 0. Okay, so instead of g of x is really like y. So when is that thing 0? All right. This is where things get crazy. I need to get x out. What do I get rid of first? Subtract the 2 first. Anything hanging off the logs that's outside of the log, get rid of that first. Okay, now I have log stuff equals -2. Now here's the thing that some of you were saying was a weakness. Now I need to go from log form to exponential. Samara, do you know how to do that for this? Not comfortable with it, okay. Leah? No? Jean Gideon?
Make the base to make the negative to the power equal the argument.
Okay. Base to the other side equals the argument. Beckham, sit up, please. Charles. So Okay, right here, 5 to the negative 2. If I want that to be a positive exponent, what is it?
1 over 25.
1 over 5 squared or 1 over 25? And this one isn't that hard. So, negative 24 over 25, so it's something a little bit less than 5. And if you're scared of the arithmetic, I'm okay with you leaving it like that. But looking at it, it's a number a little less than 5, a little bigger than negative 5. Okay? So that's graphing. Domain, Naomi, what's the domain?
0 to infinity.
This one? Ah, there we go. Domain, once it's shifted, what was that vertical asymptote? Well, starting there, round bracket, bigger, yeah.
How did we get 5 into 25 and 25?
Common denominator, this one had a, oh, yeah, how did I? Good point. Common denominator, I needed to multiply by 25, so that's 125. 124. You're right. Okay. The other properties, range, always all reals. Domain for this one, 0 to infinity. This one, negative 5 to infinity. X-intercept, set y to equal 0 and solve. And left end behavior. What's the left end behavior?
There is none.
There is none. Ain't got no left end. Because left end is as x goes to negative infinity, where's the function? Shoot, there's no function here. There's no function at negative 1. Certainly none at negative infinity. Right end behavior, very, very slowly, it is going up to infinity. Super slow.
So even if the graph is shifted left, it's still
Even if the graph is shifted left, there's no, at the end of time, negative infinity, and there's no y value. Were there other properties on the graphing sheet that you want to make sure we talk about? Yeah.
I was wondering whether
Okay, so, again, Fakir told us in the beginning that the transformation is left 5, up 2. So my real coordinate here, it's not the origin, it was negative 5, 2. I know what that coordinate is. From there, step forward 1 in the right direction, no up, no down. So from negative 5, go to negative 4, 2. So that's graphing the coordinate 1, 0 from my moved axis, my favorite stuff. I'm not going to ask you to write the numbers. Like, if you can get the coordinate right by saying, from here I'm going to go 1, 0, base comma 1, get it right on the graph. I don't need the coordinate itself written. Other issues? Okay. That was supposed to be a question, but oh well. Were there issues from any of the other graphs from yesterday? So today I have more graphs for us to practice, but people had questions on this worksheet. So should we talk about that and then do the graphing? Yeah? Okay. So using the properties to expand, how many things were multiplied in there? 3. So I'm going to end up with 3 lumps. Are they all multiplies, or are there some divides?
Multiplies.
They're all multiplies, so multiply inside becomes what operation outside?
Addition.
Addition, so plus, plus, okay, splitting them up, that's an x. This would have been a y cubed, but I want it fully expanded. What do I do with that to the 3?
Put it in front.
Comes out front as a coefficient. What do you think? Yeah? Okay, so then we were supposed to look for, in the answers, where is log x plus 3y plus log z is right here. So this is the second problem we were supposed to do. Okay, now we gotta go the other way and squish it together. So Kevin, this subtraction right here, what does that mean?
Divide.
Divide. So it's 3 divided by x, but I got more stuff. What does that plus mean? Multiply. So it's log of 3y divided by x. Arden's like, yeah, that makes sense. Arden, where's that answer? Is it on the back?
Yeah.
Okay, so Chloe, looking at that one, oh, there's more steps, oh my goodness. How do I do this one?
You would, so you would do log x to the
Okay, first thing she's saying to do is to bring in all those coefficients. Highly recommend, yes, please do that. So she said it's log x cubed plus log y squared minus log z to the 4th, okay. Then, Ally, what's the next thing you would do?
Like, make it log x to the 3rd, multiplied by y squared, divided by z to the 4th.
Totally. And I think the answer to that is on the front.
On the back.
It's on the back, okay. There it is. Okay. So Natalie, how do I squish this one together?
The x to the 4 on top, and then z, and then on bottom, y cubed.
Okay, if you can do it all at once, cool. There's not a lot to show. So she brought the exponents in, or the coefficients in as exponents. Just a second, Holiday. And this one was a positive, so it's up top. The y stuff was being subtracted, so it's dividing. And then the plus z, that's back to being multiplied. Did she get your question, or?
Not really.
Okay,
Like, why is it x and z on top instead of y and z on the bottom?
Okay, so with just arithmetic, what is the answer to that?
10.
Is it 10? Is it 2 divided by 15? Like, which way does it go?
Multiplication first.
You know, I know that's how, like, we read. I hate that. I agree it is parentheses first, then exponents, but multiply and divide, left to right, whichever one comes first. Add and subtract, left to right, whichever one comes first. So, Emmy was right, this is 10. We do 6 divided by 3, which is 2. And then we do 2 times 5, and we get 10. So Holiday up here, if you wanna do things one thing at a time, this was being subtracted, because this is subtracted, it gets divided. But that guy is now being added, that means multiply, right? So he goes up top. He's not multiplying to the y's, he's multiplying to the whole general thing. Okay, do we need to do more of these, or are you guys feeling a little more comfortable? Yes, Hessa?
Will you go over, the one?
On the back or the
up and
front?
To the right, like the one right there,
This one?
the up one.
Up one, okay. All these twos, gross. I don't know, the twos bother me, I'm gonna move them out. Cause I know how to bring it in when I need to. So Holiday, this is gonna be log something, there is a fraction because there's things being subtracted. What goes on the top?
X,
X is the only positive one, and then what's on the bottom?
X plus, and X minus.
X plus 1 and X minus 1. Okay, and then I kind of think they didn't write the answer like this. All right, gross. Multiplying that out, it's x times x, which gives me x squared, minus x plus x, those guys go away, and then the minus 1. Still got the 2, this answer isn't there. I gotta like change it somehow. Maybe I was supposed to bring that 2 in. Both of them ended up getting squared? No, it's not how they wrote it?
It was just the two with like.
The whole thing to the 2?
Yeah.
Okay. Holiday and, yeah.
Could you do the one under that? I just don't understand the wording for those ones.
Okay, but Samara, was there a question on this one still?
I think mine was similar, it was about that,
Okay, we did the one above this already.
It was like, it says use a property, yeah, it says use the properties of logarithms to write
Oh.
logarithm in terms.
Yeah,
of
okay,
log.
we'll get to that, but is it about this, Cameron? Yeah, okay.
Would you consider all of those answers right, like all the tests would be kind of like formatted different?
Um,
Same thing?
This one, I would say you're not done. You need to do that multiply.
So like the other ones?
But either of these, yeah. Okay, so the one below this and the one above. All right,
Let's do the one above, because it's just the wording that I'm confused
Okay.
on.
Oops, above that. Okay. Okay. So the wording is gross, and if you guys did it or not, either way, Beckham, sit up. This is how they might present some things on the SAT. First thing, I'm gonna peel off the exponent. I'm gonna bring that out front. To the 1/4, I'm gonna make that coefficient. And this wants me to turn things into log base 2, or log of 2 and log of 3. 12 is, can I turn 12 into 2s and 3s multiplied together? Yes, no? Sorry? 4 times 3? Okay. So that 1/4 was on both of them. I split the multiply inside out to be add across. Okay, I did too many steps at once. Are we okay with this or no? Pull it apart that way. I'm gonna distribute the 1/4 to each of them. Yep,
Can you move like the 2 squared over to the front?
I'm still not done, so 2 squared, bring that 2 out front. This is 1/2 log base 2 plus 1/4 log of, sorry, I'm saying base wrong, log 3. That's fancy. Okay. So I do want to get back to doing some graphing. And tomorrow I have a review sheet that's a mix and match of stuff, of some graphing and some of these squish and expand things. Was this enough of a going over the worksheet thing? Arden says yes. And if she says yes, yeah. Yeah, so. Take a graphing sheet and pass them back. I just, like, I can graph these very quickly. But I wanna make sure you guys can too. Yes? I checked to see that you did the classwork with the graphing back. Yep, I got it. All right, so can you guys start number 1? Oh, sorry, was there a big stack? You got one? And not to ruin your flow, but I'm going to ask people to come up one at a time to start putting the graph on the board while the rest of you are working. Alicia, can you put up the vertical asymptote? Just draw it for us.
Like the ones that got moved.
Yeah, like, and can you write it in on the properties? Oh, there too. That's lovely. Thank you. Cameron, can you dash in where the y-axis, or sorry, x-axis would have gotten moved to? It's not an asymptote, but just where would it be?
Yeah.
Okay. Tessa, can you put up what the domain would be? And Leah, can you put up what the range is? And Tim, can you put up the sketch of the graph? It's a big piece. You gotta watch your sleeves on this thing. Yeah, like the counting. So from the moved axes, where those pretend origin is, what two coordinates do we graph? And now make the pretty.
Horizontal asymptote?
There is not a horizontal asymptote, it's just our fake moved x-axis got shifted down some.
Oh.
We needed to know where to step forward to go 1, 0.
So should I bring this down?
Well, draw the graph, like connect the coordinates. Okay, thank you, yes, graphed. Emmy, how would we find the x-intercept?
6 to the up, so you'd set it.
Can you do the, it's a lot of work, I'm sorry. But Jasper, what's the y-intercept? Jasper, what do you think? What's the y-intercept? Doesn't have one. And you could either go through and calculate, but when we plug in 0, we get natural log of, log of 6 of -1. We can't do log of negatives. We can't do log of 0. So it doesn't have one. But duh, looking at Tim's graph, no, it doesn't.
Like if y equals log 6.
Okay, so here she's doing a lot of work. When is y 0 is when the function's going to cross the x-axis. So, and she used a calculator to get this number. 7,797, adding 1.
Wait, I got, for 6 to the 5th, I got 7,777.
6 to the 5th plus 1 is, yes, 7,797, 0. So just to go up 5 units in y, we had to go all the way out to 7,797. So tomorrow, or sorry, Friday, for your quiz, if you need to find an x-intercept and it's something gross like that, I am not expecting you to what I was expecting. That huge honkin' number plus 1, 0. Spencer?
Could you go to number 2?
Okay, we good with this? 'Cause number 2,
How do you find the y-intercept?
y-intercept. Y-intercept is when x is 0. Natural, ooh, wait. Yours says plus, right?
Yeah.
Okay, so what is the y-intercept of that?
There's a y log 6, 3. Oh, so you just strike that?
So, guys, the second one, it's not pretty. If it was, so Spencer, if plugging in it was log 6 of 6, or 36, or 216, something that is a factor of 6, I would expect you to evaluate, but I don't know what that is. Just, I don't know, write it like that.
Also,
Sorry,